Let's talk about the bell curve and the normal distribution. X follows a normal random variable with mean, say 20, variance, say 14 square. The notation is mu and sigma square. Here in decimals, I'm using English letters, so I use m and s square. There's no square, I'm using s. What does it mean when we say there's a bell curve associated with this normal distribution? The bell curve is actually just a function that is as shown over here, but you don't have to worry about the details of how this function came about. What you do need to worry about is how the graph looks. Let's take a look. This is the bell curve. You see that it's symmetrical to the left and to the right, right? More precisely, there is a line of symmetry x equals to m here, the purple color line, x equals to 20. When I say it's symmetrical, I mean that the area under the curve above the x-axis to the left over here, all the way to the left. Take note there is still a very, very small gap. It's the curve never hits the x-axis. There is still a very, very, very small amount of area on the left. That's the area on the left, as well as the area on the right side of the line of symmetry. These two areas are equal. Also, by the way, the area to the left here will be 0.5, area to the right will be 0.5. Area must add up to 1 because the area is probability. But that's not a main point I want to bring up here. The main point I want to bring up over here is point number 1. Line of symmetry is x equals to mu. In this case, mu is m is 20. But what happens if I now change the mu value? Let's see what happens. Let me clear the screen. If I change the mu value, I just press the play button, what happens? Whoa! As the m gets smaller, it moves to the left. As the m gets bigger, it moves to the right. The bell curve as well as the line of symmetry. That's the key idea. Okay, let me just stop this. The second key idea is, okay, let me just write that down. Disappeared already. Line of symmetry, x equals to mu. Second key idea is that as you increase, sorry, don't use s, use the standard notation sigma, you will increase the spread of the data. What does that mean? So let's see what happens as I increase the value of s. Currently s equal to 14. If I increase it, the graph becomes more spread out. Of course, the opposite is also true. If you decrease the s value, then the graph becomes less spread out, meaning that it's closer towards the mean, closer towards the line of symmetry. The data is all concentrated in the middle. Okay.